All right, so in this lesson, we are going to graph the solutions. So we're going to graph the points, the xy's really. We're going to graph the xy's to a linear equation in point slope form by using the point and slope provided. So point slope form is y minus y1 equals m times x minus x1. Once again, m is going to be our slope, our constant rate of change. This will tell us how to move, or at least that's a useful way of thinking about it. And we will also be given a point. Our point will be x1, comma, y1. So you see this x1 here, that's right there, and this y1 here, it goes right here. Now there's something that we're going to notice about this x1 and y1, but we'll see it as we go. We'll figure it out. So example 1 reads y plus 3 equals 1/2 times x plus 6. So let's go ahead and use our, well, we have a slope, right? Let's label some stuff. So this is our slope, and our point is right here and right here. It's kind of in the way, so I'm going to actually change how I showed my slope. That 1/2 is my slope. And the point that it gives me is right here. So the x plus 6. Now, this is going to seem a little weird, but this will be the opposite of what it seems like, okay? If I have a chance to, I'll explain it to you. But you see how this is plus 6? That actually means it's going to have a negative 6. You see how it's plus 3? What's going to be the opposite of that? It's negative 3. So let's try this. 1, 2, 3, 4, 5, negative 6, down 1, 2, negative 3. So this is negative 6, negative 3. And now we'll use our slope to graph the line. So our slope is 1/2. So up 1, right 2. Up 1, right 2. Up 1, right 2. And we can go backwards. And then we will graph our line, or we will graph, we will use these solutions to help us represent more solutions. There we go. Let's try it again. So our slope is negative 3. This is our slope, which is negative 3 over positive 1. So we go down 3, right 1. And then we have a point, which is right here. Okay, remember that these will look the opposite. So even though this is a negative 2, or it says minus 2, how about that? Even though it says minus 2, it will be a positive 2. And even though this is plus 7, we will write it as negative 7 here. So 2, negative 7. 2, negative 7. And we will use our slope, which is down 3, right 1. So 1, 2, 3, right 1. Looks like we run out of space, so 1, 2, 3, left 1. 1, 2, 3, left 1. Let's go ahead and attempt to make this not too crazy. So I'm about to use these 1, 2, 3, 4 solutions here to represent more solutions. Not too bad. Oh, until the end. That's good enough. All right, and example number 3. So we have a slope of 3/4. This is our slope. So positive 3 over positive 4. So we go up 3, right 4. And let's go ahead and look at our point provided. So it says -4, which means it's actually a +4. This says -5, which actually, so we're going to write +5. So let's go to 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then we'll go up 3, right 4. So 1, 2, 3. 1, 2, 3, 4. Backwards. 1, 2, 3. 1, 2, 3, 4. So we have 3 solutions. Let's use these solutions to help us represent more solutions. All right, cool. Now, I will explain to you why it looks the opposite for a moment. So let's pretend we have a point here and we just say it's like 3, 4. Well, if we take away this 3, it will look like -3. So I'm gonna write this. So I'm gonna put x minus x1 here. X minus x1. So if this is x1, even though it's positive, it's going to look like a negative. And then let's try this one. Well, I'm going to make this a -4. That's a negative. So if I do y minus y1, it's going to say y minus -4. And when you take away a negative, it'll say +4. So that's why, because it's because of the formula. So the formula says subtract, and when you subtract a positive, it looks like a negative, and when you subtract a negative, it looks like a positive. So that's it. Thank you.